Hello students, let us continue the session on pair of linear equations in two variables. Today we shall solve the questions from NCERT Exemplar 3.3. This exercise has got 22 questions. Since there are so many number of questions, we shall solve them in 2 to 3 sessions. We'll start with the first question. The first question is, for which values of lambda to the pair of linear equations lambda x plus y equal to lambda square and x plus lambda y equal to 1 have first one no solution, second one infinitely many solutions, and the third one is a unique solution. In the given equation, we need to find out the ratio of a1 by a2, b1 by b2, and c1 by c2. Then we have to see the sub-questions. For no solution, we will be considering a1 by a2 equal to b1 by b2, not equal to c1 by c2. Then infinitely many solutions, we will consider them as all equal. So for unique solution, we will consider a1 by a2 not equal to b1 by b2. Let us solve that. So first let me find out the ratio of a1 by a2. I'll write it here, a1 upon a2, which will be lambda upon 1, b1 by b2, which is 1 by lambda, c1 upon c2 is lambda square upon 1. Now with these ratios, I have to consider each sub-question. Let me consider the sub-question no solution. We all have learned the equation will be having no solution when the lines run parallel to each other. The condition for such type of lines will be a1 upon a2 equal to b1 upon b2, which is not equal to c1 upon c2. Here, if I use this condition, a1 upon a2 is lambda by 1, which is equal to b1 upon b2, which is 1 by lambda, which is not equal to c1 upon c2, which is lambda square upon 1. Consider this portion. Consider lambda by 1 is equal to 1 by lambda. Integrating lambda square equal to 1. So lambda is plus or minus 1. So there are two values of lambda here, positive 1 and negative 1. If we using lambda equal to positive 1, we get a1 upon a2 equal to 1 upon 1, b1 upon b2, which is equal to, again it is 1 upon 1, c1 upon c2 will be also 1 upon 1. If you observe here, a1 upon a2 is equal to b1 upon b2, which is equal to c1 upon c2. Therefore, this condition is, you have to reject it, reject that. So let me use lambda equal to minus 1. So using lambda equal to minus 1, we get a1 upon a2 as minus 1, b1 upon b2 as minus 1, and c1 upon c2 is lambda square. Minus 1 square is positive 1, so positive 1. Therefore, we are getting a1 by a2, which is equal to b1 upon b2, which is not equal to c1 upon c2. So this suits, therefore the value of lambda is minus 1. So we have solved the first one. Now we have to take up the second case, infinitely many solutions. For infinitely many solutions, the condition is a1 upon a2 equal to b1 upon b2 is equal to c1 upon c2. Substitute the values. a1 upon a2 is lambda upon 1, b1 upon b2 is 1 by lambda, which is equal to c1 upon c2, which is lambda square upon 1. Now if we consider lambda upon 1 equal to 1 by lambda, we get lambda square equal to 1. Once again, we have lambda values equal to plus or minus 1. And consider 1 by lambda equal to lambda square by 1. If you consider this part, we will be getting lambda cube as 1. Therefore, lambda value is 1. In these two equations, lambda square equal to 1 and lambda cube equal to 1, the common solution is lambda equal to 1. So I have to consider that as a solution. So value of lambda is positive 1. Now let us consider the third part for a unique solution. We know the condition a1 upon a2 is not equal to b1 upon b2. Therefore, I have to substitute the value and be getting 1 by lambda not equal to lambda upon 1. Therefore, we get lambda square not equal to 1. This implies lambda value is either positive 1 or not equal to positive 1 or negative 1. So what does this inequality refers to? It refers to any real number or any real value except plus or minus 1. Let us solve the second question. For which values of k will the pair of equations kx plus 3y equal to k minus 3 and 12x plus ky equal to k have no solution? So what is the condition for having no solution? The condition is a1 upon a2 equal to b1 upon b2 not equal to c1 upon c2. So let me first find out a1 upon a2. a1 upon a2 is k upon 12. b1 upon b2 is 3 upon k. c1 upon c2 is k minus 3 upon k. Now with this I have to use it for Condition for no solution is a1 upon a2 equal to b1 upon b2, which is not equal to c1 upon c2. Substitute a1 upon a2 is k by 12, b1 upon b2 is 3 by k, not equal to c1 upon c2 is k minus 3 upon k. Now consider this equal part. We have k by 12 equal to 3 upon k. If you cross multiply, we will be getting k square equal to 36. Therefore, the value of k is plus or minus 6. And consider 3 upon k not equal to k minus 3 upon k. If you consider this inequal part, we will be having, if you cross multiply, we will get k square minus 3k not equal to k. If you transpose this 3k which is there in the right hand side to left hand side, we will be getting k square minus 6k not equal to 0. If you take k common, we will be getting k minus 6 not equal to 0. This implies the value of k shouldn't be 0 and k minus 6 should not be equal to 0. This implies that k value is not 0 and k value is not 6. Therefore, the value of k should be taken as negative 6. Here we got plus or minus 6. You have to observe this part, plus or minus 6. Then we have considered this inequality and we have found that the value of k should not be positive 6. Therefore, the value of k is taken as negative 6. Let us solve question number 3. For which values of a and b will the following pair of linear equations have infinitely many solutions? The condition for infinitely many solutions is the ratios must be 12. Let me write that directly. For infinitely many solutions, consider a1 upon a2 equal to b1 upon b2, which is equal to c1 upon c2. Substitute the values, we will be getting a1 upon a2 as 1 upon a minus b. b1 upon b2 is 2 divided by a plus b. 2 divided by a plus b. And c1 upon c2 is 1 upon a plus b minus 2. Let me consider the first part, 1 upon a minus b equal to 2 upon a plus b. If I consider this, let me solve this equalities. If you cross multiply, we will be getting a plus b equal to 2a minus 2b. You have to solve this equation. If a is brought this side, we will be getting 2a minus a. If 2b is taken to the left hand side, let b added to 2b, we will be getting a value equal to 3b. This is the result I have obtained and call this as equation 1. Now I will consider 2 upon a plus b equal to 1 upon a plus b minus 2. Now if you cross multiply, you'll be getting 2a plus 2b negative 4, which is equal to a plus b. If a is transposed to left hand side, you will be getting a. If b is transposed to left hand side, you will be getting positive b equal to 4. Use equation 1, we get 3b plus b equal to 4. This implies 4b equal to 4. The value of b is 1. Therefore, a value is 3b. We get 3 times of 1 equal to 3. So a value is 3 and b value is 1. Very simple. Let's move on to the next question. Fourth question. It is very lengthy question. Find the values of p in equation 1 to equation 4. Sorry, question 1 to question 4, and p and q in question 5 for the following pair of linear equations. There are 5 sub questions here. Let us take up one by one and then solve them. The first question is 3x minus y minus 5 equal to 0, and 6x minus 2y minus 2 equal to 0. If the lines are represented by these equations are parallel. Let me write the equation here. The equation is 3x minus y minus 5 equal to 0, and one more equation is 6x minus 2y minus 3 equal to 0. They have given that these equations, they represent parallel lines. So the condition is a1 upon a2 equal to b1 upon b2, not equal to e1 upon c2. Let me find out what is a1 upon a2. It is 3 upon 6, nothing but 1 by 2. b1 upon b2 is negative 1 upon negative 2, nothing but positive 1 by 2. And c1 upon c2 is negative 5 upon negative p, which is 5 by p. Now let us use the condition. For parallel lines, we have a1 upon a2 equal to b1 upon b2, which is not equal to c1 upon c2. Substitute the values, we will be getting 1 by 2 equal to 1 by 2, not equal to 5 by p. Now we have to consider this portion 1 by 2 not equal to 5 by p. If you cross multiply, you will be getting p not equal to 10. What does p not equal to 10 refers to? It refers to all the real values except 10. Let me write it here. Therefore, p is all real values except 10. The second question is, they have given the equations as minus x plus py equal to positive 1 and px minus y equal to positive 1. and they are given that there is no solution. Here, what is a1 upon a2? It is minus 1 upon p. b1 upon b2 is p by minus 1, and c1 upon c2 is 1 upon 1. For no solution, a1 upon a2 is equal to b1 upon b2, not equal to c1 upon c2. Substitute the values negative 1 upon p equal to positive p upon negative 1, not equal to 1 by 1. Let us take up this equal part here. So minus 1 by p equal to p by minus 1 equal to 8. We will be getting p square equal to positive 1. Therefore, the value of p is plus r minus 1. Now, which value should we consider? Should I consider plus 1 or should I consider minus 1? I have to check it out. For that, let me take separately if p is equal to 1. What will be the value of a1 by a2? It will be minus 1. b1 upon b2. This will be again minus 1. c1 upon c2. We have positive 1. Therefore, a1 upon a2 equal to b1 upon b2, not equal to c1 upon c2. We get it for p equal to 1. What if p value taken as negative 1? If p value is taken as negative 1, we have a1 upon a2 equal to positive 1. b1 upon b2 is positive 1. c1 upon c2 is also positive 1. So which means a1 upon a2 equal to b1 upon b2, which is equal to c1 upon c2. This condition should not be there for no solution. For no solution, only this part a1 upon a2 equal to b1 upon b2, not equal to c1 upon c2 should be there. So this part is rejected. So the value of p should be equal to 1, should not be minus 1. So we have solved fourth question in the first and the second question. These three questions and the remaining questions we will take up in the next session. Practice these questions and the remaining 18 questions part by part we will see. We will try and understand